In the last video, we came up with the term for let's say sine 45, cos 45, and tan 45 by creating a simple triangle like this. This is one, this is one, so we know that this must be 45. Okay, and then from this, we use Pythagoras to work out that this length here is root 2. So from this, we came up with we know that that this is cos, isn't it? We know that cos 45 equals 1 over root 2 and so on, and tan here is this, but tan 45 is actually 1 over 1, which is 1. Well, by creating simple shapes like this, we can come up with terms for certain angles. So here we came up with terms for sine 45, cos 45. Well, we can use the same technique for other angles as well. So look at this here. I'm going to try and show you terms for let's say sine 30 or cos 60. Okay. Well, things like that. Well, look at this here. Look at this triangle. Let's say this one here is 2, 2, 2. This is an equilateral triangle. We could use 1, but 2 is actually easier. It will still work for 1, 1, 1, or 10, 10, 10, or whatever. But 2 is actually easier. You see why in a minute. If I split this down here, this is an equilateral triangle, remember? Oh, wait there. If this is an equilateral triangle here, we know that all the angles inside a triangle adds up to 180. If this is an equilateral triangle, then this angle here must be the same as this angle, must be the same as this angle here. So we can get 180 divided by 3. Okay, so that becomes 60. Sorry. So this angle here is 60. This angle here is 60. This angle here is 60. Now, if we split this up straight down here, okay, so this angle now is the same as this angle here. So it's actually 30 now. This triangle here, it's 30. So let me draw this again. So this here, okay. Remember, we're saying that this is 2, this is 2, and this is 2. This angle here is 30 degrees, and this angle here is 60 degrees. This is 2. Well, if this is 2 here, this must be 1 from here to here. Must be 1. So we know that this is 1. We don't know the height yet. Well, we can use Pythagoras to find the height. Let's call this x. Okay, x. Oh, wait there. The longer side is always on its own. So 2 squared. We are using Pythagoras now. 2 squared equals x squared. Looking at this one here, we are using Pythagoras. 2 squared equals x squared plus 1 squared here. Okay, so plus 1 squared. Try and work out what x is now. So this will be 4 x squared over here. This will be 1 times 1 is 1. Now take away 1 from both sides, so that will be 3 equals x squared. So x equals root 3. Okay, so what I'm trying to say is that if you have an equilateral triangle, 2, 2, 2, the height here is actually root 3. Okay, so let me put root 3 in here. Root 3. So this height here is root 3. Now we can use a normal. Hang on, let me clear this up. So now we can use our normal technique here. So let's say sine 60. So sine, well, our imaginary sum will be here. Okay, so sine 60 is like that. So we know that sine 60 will be root 3 over 2. Okay, now if you don't believe me, punch into your calculator sine 60. Remember, you're working in degrees, okay? Don't make sure your calculator's on deg and not radians, not rad. Okay, we are using this. This is for rad is for radians is for when you're older. You will use radian, but here you use degrees. So so punch into your calculator sine 60, and then you will get to a number. Okay, well this number here will be the same as square root of 3 divided by 2. It will be the same as that. Okay, and again we can use it for. Hang on, let me clear this up. Okay. Oh, hang on. Let me clear this up. Bear with me. Okay, now we can use the same technique. Now, we could use tan. We could use. We could use tan 60. So tan 60. Tan 60 equals, well, tan would be like this, wouldn't it? So tan 60 would be root 3 over 1, which is just root 3. Okay, so if you don't believe me, then punch this into your calculator, tan 60, and that will be the same as square rooting 3. Okay, now what's the other one? Cos 60, well, cos 60 would be this. Cos 60 equals 1 over 2. So if you don't believe me, then punch into your calculator cos 60, whatever that number is, that would be the same as 0.5. Okay, and also you can use this angle here by looking at the 30 and not the 60. Okay, now looking at 30, whether now just looking at 30. So let's say tan 30. Okay, well tan. If we are looking at 30, our sum will be over here. Okay, this is getting messy. So let me jump down here. Hang on. This is 30 here. We are just looking at 30. This is 2, this is 1, and this is root 3. Okay. Now, if we are looking at 30, then our imaginary sum would be down here, and this is the c here. Okay. So if, tan 30. Let's just look at tan 30. Tan 30 would be well, the sun is here coming down, giving you a sun tan. So tan 30 would be 1 over root 3. Now, if you don't believe me, punch this into your calculator, you will get a number. Well, this number here will be the same as 1 divided by root 3. Okay? And if you look at sine 30, well, sine 30, let's see, sine 30 would be this. The sun is here, going up here. So sine 30 would be 1 over 2. So sine 30 is actually 0.5. Okay, and now what was the last one? Cos. If you look at cos 30, that equals cos 30 would be a cord jumping out of the water here. So if you cos 30, it would be root 3 over 2. Now, if you don't believe me, punch cos 30 into your calculator, and that should be the same as square rooting 3, whatever that answer is, divided by 2. Okay, so yeah, try on your calculator if you don't believe me. In the next video, I will show you some more techniques into finding other angles. Okay.